Welcome to the third of the halogen videos. I'm having a bit of problems uploading the second video, so this may end up being the second video. But anyway, it should be the third video. In the last video, which hopefully has been uploaded and you've watched, we looked at, as you can possibly see from this slide, the reaction between chlorine and hydrogen. We also looked at the reactivities of the halogens, and we said that the reactivity of the halogens decreased as you go down the group, and that was because the atoms, and I'm just going to let's see if I can draw, here's fluorine and here's iodine. So as you can see, as you go down the group, the size of the atom increases. Now halogens react by gaining an electron, and the thing that attracts the electrons to the atom would be the nucleus, because the nucleus is full of positive protons, so it drags in the negative electrons. So the closer the nucleus is to the outer shell, the more likely it is to attract that extra electron. So fluorine is the most reactive of the halogens because its outer shell is nice and close to the nucleus, so it can drag in that extra electron from another atom. Iodine won't be as attractive to an extra electron because its nucleus is further away from that outer shell. So the nucleus will be here, so the distance is greater, so the attractive pull between the positive nucleus and the outer shell is less. So let's see how that affects displacement reactions between halogens and halides. So hopefully you've got a reasonable idea of how a displacement reaction works. So a displacement reaction occurs when a more reactive element displaces a less reactive element from a compound. So let's see how the halogens interact. So on this left hand side of the table we've got the halogens, so we've got Cl2, we've got Br2 and I2, and then we've got compounds containing those substances. We've got potassium chloride, KCl, we've got potassium bromide, and then we've got potassium iodide. This would work equally well with sodium chloride, sodium bromide and sodium iodide. So is chlorine, and obviously we're not going to bother with these middle ones because we've got matching halogens in those squares. So the first reaction we're going to look at is the possibility of chlorine reacting with potassium bromide. So what we've got to consider is chlorine more reactive than bromine? And chlorine is more reactive than bromine, so chlorine is able to displace the bromide from the compound. So we'd have a reaction that combined Cl2 and KBr, and what we would form is the chlorine would come in and kick the Br out, so we would form KCl and Br2. Now obviously that equation needs balancing, so you'd have 2 KBr and 2 KCl, and it's nice and balanced then. Now what you might be thinking is, hang on a minute, why not just form KCl2? And that can't happen because potassium has a valency of 1 and chloride down here also has a valency of 1. So the formula of potassium chloride is KCl. Now what might you see if you actually did this reaction? So if we had chlorine, which was maybe dissolved in water, so chlorine water, and potassium bromide, which was also dissolved in water, what we would see is bromine being produced in the aqueous solution. Now what does bromine look like in an aqueous solution? Bromine water, effectively, is orange. So we would see two colourless liquids coming together and an orange liquid of bromine being produced. A little bit of bromine might actually evaporate out the solution, so you may see a few orangey brown fumes, but I think that's very unlikely. So you'd see an orange liquid being produced. Now let's see if chlorine has the ability to displace the iodide forming iodine. And it does, because the chlorine is more reactive than iodine, so displaces it. So you'll get a very similar reaction occurring. And you might already be thinking, what would I see if I actually did that reaction? Well, here we've got chlorine, which would be a colourless solution. We've got potassium iodide, which is a salt solution, so also would be colourless. And then we produce potassium chloride, which dissolved in water is colourless, and iodine, which would remain dissolved in the water. Now the iodine produced, well, we said I think in the first video, that iodine, when it's dissolved in water, is a sort of brown colour. So we'd be producing a brown liquid in this reaction. We go from colourless to brown. And you might think, well, actually, these two things, bromine water and iodine, are probably going to look a little bit similar. And you'd be right. And if you were really wanting to prove that you'd made iodine rather than bromine, I mean, you would never make up bromine, would you, in this reaction here, because you haven't actually got any bromine, but you could add a little bit of an organic solvent. And if you added the organic solvent, the iodine prefers to dissolve in the organic solvent rather than the aqueous solvent, and bizarrely, iodine in an organic solvent actually is purple. We mentioned this in the first video. So when it was aqueous, you'd get a brown solution, put in a little bit of an organic solvent, and that organic solvent would turn purple due to the iodine. Right, chlorine we've done. So let's have a look and see if bromine has the ability to displace the chlorine. Let's have a think. Will bromine displace the chlorine from potassium chloride? And it won't. Bromine is less reactive. Stumbling over my words there. Bromine is less reactive than chlorine, so the bromine cannot displace the chloride here. So you get no reaction, because the bromine is less reactive. So no reaction would occur. Would it react here? Well, it would, because the bromine is more reactive than the iodine. So the bromine will displace the iodine. So you get a reaction occurring. Good old displacement reaction. I'm just going to finish the till off there. And here, what would we see? Well, we've got bromine here, which would be dissolved in water. We're not going to do this in pure bromine. And we form iodine. All these things are dissolved in water. So bromine water is an orange colour. Iodine is a brown colour when it's dissolved in water. So we'd probably see a darkening of the orange to form this brown iodine solution. And we could prove that iodine was in there by adding the organic solvent, which would turn purple. Onwards, will iodine react with any of these? The answer is no, because iodine is not as reactive as chlorine, or iodine here, not as reactive as chlorine, and not as reactive as bromine, so it doesn't have the power to displace them. Now next we're going to look at a little bit more detail about these reactions in some ionic equations.